Welcome, guys. So we're going to talk about the state of Wi-Fi 6, and we're going to do that. We're going to talk about the state of Wi-Fi 6 from our standpoint, from the Wi-Fi, from the Wi-Fi engineer standpoint, and so that's why I added in practice, right?
With an S.
Yeah. So that's who we are. So in the presentation, we put a lot of links, a lot of resources. So if you want to go to this website, jetson.net/WLPC, you're able to download the PDF of this presentation and click on the links as we go if you want to. So define Wi-Fi 6. So I started with that because it sounds like a pretty easy statement, right? You could probably answer it in one sentence, but if you start thinking about it, it's going to take you a longer time to just understand what it's going to mean for us Wi-Fi engineers on our day-to-day work. And it reminded me of when I was in high school in France. They used to have this philosophy class, and then for the exam, the student would just give us a philosophical statement. So he would say, "Can we escape time?" And then he would say, "You have 4 hours," and we just have to think about it and come up with something right about it, and then give the answer to him. So that's kind of like what we did with Rowell, trying to define Wi-Fi 6. What does it mean for us?
So is this going to be 4 hours long?
No, this one 53 minutes and 28 seconds. So how do we design for Wi-Fi 6? How do we support Wi-Fi 6 networks? What devices do we have available out there today? And that's kind of like what we try to focus on in this presentation. And then we come up with, how do we present that stuff to you guys? So we came up to 3 big sections. The first one would be talking a little bit about the theory behind Wi-Fi 6. Then we talk about the equipment, the one we use for our labs, the one we have available today on the market, on the AP side, on the client side. And then at the end, we talked about the practice, like the test we did, and what did we notice doing our test? What was our experience working with Wi-Fi 6 devices today?
Right. So as you say, we went through the process, right? So first we'll go through the theory. We're going to go briefly over it because there's a lot to go through. Then we're going to talk more into the equipment that we actually use. So if you want to try this out, you can do it too. And then the actual test that we performed. And for this presentation, we did a very basic test just to see, turn on the AP, connect the client, leave all the default settings, right? So we'll see how the clients actually interact with Wi-Fi 6.
So if you want to join the conversation, you can do that on Twitter. Please use this Twitter handle so people watching this video online on YouTube later on, 2 months down the road, they'll be able to go back and see what you are talking about. So what we're presenting is whatever we've noticed doing our test using the equipment we had. But I know some of you guys work for vendors, so you might have different experience. So if you want to add more values to our presentation and tweet about what you've experienced in your own lab, please feel free to do so and use the hashtag so we can benefit everyone. So working with Wi-Fi 6 devices, what we realized in practice is that we're still early age. So Keith likes when we put our conclusion at the beginning. So that was pretty much the easy conclusion of working with Wi-Fi 6 devices. And then I looked at the Gartner hype cycle, so I wanted to understand, Wi-Fi 6, we've heard about it for a while now, or AX, WLAX, and that's where they place it on the hype curve, right? So it's a peak of inflated expectations, started to go down, and just as a reference, this is where Wi-Fi 5 or 802.11ac is as a reference. So just before we get into it, we wanted to do a quick survey. So how many of you guys own a Wi-Fi 6 device?
Oh, wow.
Okay, so you would say?
That's like?
It's like 25%? 30?
25, 30%.
27.5? All right, sure.
All right, you're doing the math at the end.
How many of you have ever deployed a Wi-Fi 6 network? I mean for a customer, not in your bedroom.
No lab. No lab.
That's like
That's less than 1%. That's 0.5.
I would say one person. Let's round it up. Have you ever connected to a Wi-Fi 6 network that's not yours? Interesting. Okay. So let's say one person. So as you can see, in practice, we're still early age. All right, thank you guys. No, we just wanted to do this to just prove the point a little bit. All right, let's get into the theory a little bit. AX, 802.11ax, or Wi-Fi 6. Here are the documents we used to document ourselves.
Yeah, we primarily use the draft document. I think we started at draft 3, and we talked about this on our podcast, going through the different features of Wi-Fi 6. So we've read the draft multiple times, and then we started looking at other vendors' documentations because they will make it a little bit more easier for us to understand as engineers. And so we took a look at Aruba's, Cisco's, Aerohive's, just as much information that we can gather and see it from the vendor's perspectives, and then try to align that with what we interpreted from the draft document, and then try to put it in practice. And then we also use the CWNA book from David and David, or Westcott and Coleman, however you want to say. I like calling it David and David. And then there's also a document from the Wireless Broadband Alliance, which I actually thought was a good document because it kind of outlined the approach to take with Wi-Fi 6 versus the theory.
So sometimes when you read the white papers from the vendor, it feels like it's written by people that also work, on the draft, but it's written in English, like, so you can actually understand. So what did we learn? First, we learned about the objectives of AX, right? So this is known. We're going to have more and more Wi-Fi devices. So good news, Wi-Fi is not going anywhere. 5G is not going to replace Wi-Fi, so we're safe. And then we're going to have different type of devices connecting to our Wi-Fi networks, IoT, AR, IoT, low power, low data rates, demand. So different type of devices with different type of demand in terms of network standpoint. So that's kind of like, that was the premise for AX. And the solution was to make the 802.11 protocol more efficient, okay? Hence the HE name. How did they do that? Technical solutions. So here you see we put a whole bunch of technical solution with the acronyms next to it. So we don't have time to go in deep into all of this, but if you go back to the resource we talked about it, you can find more information.
If you just read the draft, it's all there.
Yeah.
But this is not everything. This is just some of the big technologies from the draft.
So the idea from this slide is to say that Wi-Fi 6 or AX it's not just one small features that get added to the Wi-Fi protocol. It's a whole bunch of new enhancement. Actually, some of them are not new. They are just borrowed from other 802.11 amendment, and they cannot use that to enhance Wi-Fi communications. If you look at the draft, right? That's a draft. We put a link here. You can get it for yourself if you pay 400 years. And if you look at the number of pages, 746 pages, right? The current standard, the 2016, has 3,500 pages. So that's plus 20% that this new amendment is bringing. Just to tell you guys that it's going to bring a lot more complexity. And when you look at the draft, you see a whole bunch, just like any network technologies, we have a whole bunch of acronyms. That's just a few I was just keeping track of when I was reading the draft. If you look at the timeline for the AX amendment, it started back in 2014. Then they have 4 versions of the draft. The latest one is February 2019, draft v4. And if you look at the IEEE website, we put the link here, there have the ratification date for 2020. It's funny how they keep pushing it back, right? So for now, today, I guess that's what we have. So what about the Wi-Fi Alliance? So Wi-Fi Alliance, last year, they announced new naming, right? So we're going to have Wi-Fi 6, Wi-Fi 5, Wi-Fi 4, right? And so how is this going to affect us? It's more from the user standpoint, I guess. When they connect with the Wi-Fi 6 device, if everything is set up properly, they will see their Wi-Fi 6 icon, and they'll feel good about themselves. And I didn't spend all that money for nothing. Now I have my icon. And that's pretty much what the WFA is saying. So that's, you notice how I put the title? I'm not going to. And so this is what you'll see on your phone. And then certification, right? So last month, I think 3 weeks ago, they released publicly their Wi-Fi 6 certification, and they gave us a nice graph outlining some of the key features of the certification. What's challenging for us is that the information they release publicly is not the same information that you would get if you're a member of the Wi-Fi Alliance. So the vendors, they're usually members of the Wi-Fi Alliance, so they can get the test requirements, and they can test the IP and stuff like that. For us, all we had available to us was the publicly available documentation. So we tried to see in the publicly available documentation what we could get out of there. And this is what we came up with. So that information might not be 100% accurate, but that's what we understood from it. So you have features that are mandatory. They don't say explicitly, it just says key enhancement of the protocol. So OFDMA, multi-user MIMO, and so on. And for example, BSS scoring, optional. David, can you confirm that?
No, that's all good.
Okay.
I'll just add that the uplink and downlink OFDMA is testing for 4 RUs.
Okay. Perfect. I might explain some of the stuff.
Yes.
Okay. You know this WPA3, right? WPA3 is a requirement, also Wi-Fi Agile multiband, right? Which is nice because they have, in the Wi-Fi Agile multiband, they have neighbor reports, some of the K features, so we'll inherit that in AX as well for the client devices, which is nice. Did the Wi-Fi Alliance start certifying devices? Yep. Yeah? As of today, 42, that number changes every day. I had to update my presentation every day.
I just kept watching Francois refresh the page.
So I'll show you how we can get that information. But as of today, 42 devices are now certified Wi-Fi 6. The first client device to get certified was the Samsung Note 10, and the first access point to be certified was the Ruckus R750. How do we get that information? On the Wi-Fi Alliance website, you can go to the product finder, and when you go to the product finder, first you search using the model number, right? So here I was searching for my phone. I have a Galaxy S10. Notice how I didn't write Galaxy S10. So you have to go and get the model number, and then when you search for it, you'll get the results. And then so here I could find my phone, and then you can actually download the certificate, and in the certificate you can get, you'll see different tiles that says Wi-Fi 6 certification, and here you get a little bit more technical details, right? And if you're going to find stuff you don't know existed, and so that's when you go back to the draft and do your research to understand what all of that is. So here, sorry, that wasn't my phone, that was the Note 10, because my phone I don't think is certified. So if you search like my phone, for instance, you won't see any Wi-Fi 6 certified tile in the certification PDF file. So in terms of Wi-Fi device equipment, we've come the long way. I was doing this stitching in Belgium one day, and then one of my students, he brought me a 99 AP and 99 client. And then I had my Wi-Fi 6 AP and my client, so this is pretty much the evolution of Wi-Fi. So in terms of access points, so now pretty much Rowell calls it the
race to Wi-Fi 6 NASCAR sled.
Yeah, so we have, so pretty much every vendor now have their Wi-Fi 6 access points, even enterprise or consumer residential space. And then we have different names for them, right? We have Wi-Fi 6 compatible, Wi-Fi 6 certifiable, Wi-Fi 6 certified. So what does that mean? So I was trying to find an analogy for all of this, and this is the one I found. We'll see if it works. But so you know how when you buy the AirPods from Apple, right? You pay a lot of money, but you know it's certified by Apple. You know everything works, the protocols, the self-pairing, and all of that. So you're happy about that. Justify the money, I guess. But if you go online, you can buy the exact same one for half the price, and it also supports automatic pairing, and it just looks like an airport. You can still listen to your music. So that would be like the certifiable, meaning they meet all of the Wi-Fi Alliance criteria, but they haven't been tested yet. I'm guessing one day they will become certified. And then you have the compatible, like the knockoff AirPod you buy, and all you can do is pair Bluetooth. You don't have the automatic pairing and all of that good enhanced features. Does it work? I don't know. Online also, if you go to this website, the wikidevi.com, and I got it from Jerry one day, he shared it. Thank you, Jerry. And then we created this table. They kind of go over all the chipsets you find in different access points from different vendors. So you can see Broadcom, Qualcomm, Intel, and Marvell are the main ones. Yeah. I'm not saying we put everything on here because it was possible. What we found. Yeah, and you can see a couple of examples of access points as well. So going back to the Wi-Fi Alliance website, the product finder, how do you find the Wi-Fi 6 certified product? Well, you can just make sure you select the Wi-Fi 6 certified checkbox under features, and then you have something called routers. So you know, sometimes the customer, they call AP routers, so it's kind of the same. So here's the access point, and then we have, this is what we had 2 days ago. I didn't check today, maybe we'll have a couple more. But so this is what we had today. So, and then what I've noticed too is if you go to, instead of selecting router, but you select other, then you're going to have another subset of devices, and some of them have AP in their name. So this is when it gets confusing. You don't know, is it an AP, is it not an AP? And then if you take this number and you do a Google search, you end up going back into the Wi-Fi Alliance website on the product finder. So it's like, it's hard sometimes to find the information. The chipset manufacturer will have different name for their chipsets. So it's hard sometimes to correlate the information. And look what's funny here. If you look at other devices, they have STA in their name. So like, is it an AP, is it a station? So the other, I guess the other could be both. Yeah, gonna have to drill more to get more information.
So in terms of what's supported today, we have our mobile devices at the top, Samsung and Apple, and so a lot of us upgrade every year, or a lot of consumers upgrade every year, so this is how we're gonna see this transition play out fairly soon, right? So we'll see a lot of Wi-Fi 6 devices start to ramp up. And then here on the bottom, we have the chips that we've tested. I use the Intel AX200, you can purchase that one online and get it directly shipped from China, plug that into my Lenovo. I think I was using a T440N. And then you have to get the right drivers, so make sure you download the drivers with your laptop first, and then replace your Wi-Fi card. And then you could be able to test it with a Wi-Fi 6 AP. And you'll see in this demo, if it runs right, we're using some of the, actually the same chip, the Intel chip, on a NVIDIA Jetson Nano.
Yeah. So for the phones, we have the Samsung and the Apple. So Samsung, we've had them for quite a while now. Some of them are certified, as you can see at the bottom. You have the Galaxy Fold. Anyone has a Galaxy Fold?
Not yet.
No, yeah. And then Galaxy Note. And then for Apple, so there is the iPhone 11, which is compatible. And then I couldn't find the information to know exactly if it's certified or not. That's the information I found online, that it's using that chipset, but not sure.
Apple never certifies their devices.
Okay, so here we go.
Yeah, that's the thing too.
Yeah, I did a search on iPhone. The latest one was iPhone 5, so I was like, okay. But I was thinking maybe it's using one chipset that's certified.
Does anyone here have iPhone 11?
Yeah. Okay,
right,
good.
So do you have an iPerf app? iPerf 3 app? All right, good.
Yeah, keep them up. So that for the phones. For the computers, so right now we pretty much have the Intel as an option. And by the way, all the clients today, they're only 2x2x2, right? We don't have 3x3, 1x1, or so anything else.
That's a limitation of our test, is 2x2x2.
And so Rowell, he put it in a Lenovo laptop. What you can also do is purchase this little guy, the NVIDIA Jetson Nano, and this is pretty much a computer they created to do AI testing. But it has the M2 connector, so you can actually connect the Intel chipset in there, and it's running Ubuntu, so you can install the Ubuntu AX drivers to be able to use the card on Ubuntu, right? So we use that as well. Because it's a pretty inexpensive way of getting an AX client.
Which we have right up here, so if you want to see it afterwards, you can take a look.
Yeah. Are you selling them?
So I want to actually give a shout out to John Kilpatrick. I don't think he's here, but he has a good blog post on how to set this up, what equipment to buy, and get it up and running.
And then you also have this option where you can actually buy a PCI board that supports the M2 connector, put the AX chip in it, and then you put that in an enclosure like this one you see over here. You get Thunderbolt 3 connection, and you can connect that to your PC or Mac. And you have a link here, and the guys from Tamosoft, they use that for their test, and they document everything, so if you want to get more information. This option is a little bit more expensive, though, because the box is like $300, I think, so it's expensive, but it's doable. All right, let's talk about the practice now. So our process was to just try to do some tests, right? And we wanted to test different Wi-Fi 6 features. We wanted to test the ones that are mandatory from the certification program. And so we went ahead and we designed a whole bunch of few tests, actually a lot of tests. And
a lot of the same tests on multiple APs, like a really simple test, and we'll see it as we do the demo.
Yeah, and then we ended up doing some simple tests, and then we want to talk about our experience doing those tests and what it meant for us. I don't think we're done. We're planning on doing more, and we'll talk about that later as well.
We had to do enough for the presentation.
Yeah. So for the testing, we used the equipment we had. So we had a couple of Cisco access points.
Yeah.
This is a Samsung phone. Then we have Aruba.
That was a 514.
514. And you can see Rowell's skills taking pictures. If you need a photographer for your wedding, it's wrong. We had the Arrive 630. We had a couple of Ingenious 357, 377. And this is the Jetson Nano that we used. It's over there. It's
That's the actual one. And for the demo, we're using the Arrive.
Yeah. I love how you say it's the actual one. It's like car number one. You know when they present the car? That's model number one. And so to present our results, we kind of divided it in 3 sections. The first one is Wi-Fi 6 operations. So how would this new technology affect our day-to-day job? Second one, we want to talk about Wi-Fi 6 analysis. How do you monitor Wi-Fi 6 communications? And the third one would be Wi-Fi design. We want to talk about that a little bit. So for the operation, first, Wi-Fi 6 doesn't mean OFDMA. So what I mean by that is, at first I thought that all Wi-Fi 6 communications were going to be OFDMA communications. But in fact, Wi-Fi 6 or AX is still using OFDM, right? So you're going to see both OFDM and OFDMA traffic when you do Wi-Fi 6 analysis. And one of the big changes you're going to see when you start analyzing Wi-Fi 6 communications is data rates, right? If you take a look at how we calculate OFDM data rates, what we do is we take the number of subcarrier, right, and then we multiply it by the number of useful bits we can encode on the subcarriers. And these 2 key values are changing with 11AX, right? So all of that will pretty much change all of our data rates. Remember in N and AC, if you had an MCN4, you pretty much had the same OFDM data rate. Now, if you have an MCS4 on AX, it's a totally new data rate because we don't have the same number of subcarriers and we don't encode the same number of bits in the subcarriers. On top of that, we also changed the symbol duration and we changed the guard intervals, right? We now have 3 different guard intervals, all right? So what does it mean in terms of data rates? They all change, and plus we have more of them.
A lot more.
Yeah, we have I think it's 2,880 day rates we have in total if you look at all the features supported by the standards. So that's for OFDM if you use AX. And what about OFDMA? It's pretty much the same, except that in OFDMA, instead of talking about channel width, we talk about resource units. So you need to understand how many data subcarriers you have in your resource units and pretty much how wide it is, and how many encoded bits you have depending on your modulation techniques. Okay, but it's pretty much the same calculation afterwards. So what
does it look like?
Yeah, what does it look like? So this way. So this is the updated MCS table, right?
Yeah. In the previous slide, there's a link to the actual sheet, and it goes up to 8 spatial streams. So that's why it's
that's why it's pretty big. So as you, I don't know if you can see, but I was going to say as you can see, but on the green and the orange is the AC and N, and the blue it's AX. The turquoise blue, I guess I would say, is the OFDM, and the blue is the OFDMA. Okay, so if you zoom into, I tried to zoom a little bit into the Wi-Fi 6 data rates or AX data rates, and here we only kept the first 3 spatial streams. Actually, we could have kept only 2 spatial streams because that's what clients have nowadays. And so pretty much if you use OFDM, you're going to see your data rates here. And you can see the different channel width, 20, 40, 80, and 160. And then for OFDM-A, what you have is the number of tones that you have under your resource units, right? That's how pretty much how they define the baby channel, as David likes to call it, right? And what's interesting, if you start to look at the baby channel, is that you realize that the maximum RU size is actually equivalent to 80 megahertz wide channels, right? So you will get better data rates if you use OFDM using AX versus if you use OFDMA, right? Remember, it's all about better efficiency, not necessarily better data rates. So if you start looking at the MCS table, and you notice that here, if this works, here you start getting 3.6 gig, awesome. And then if you look at the maximum you can get with OFDMA, 1.8, what's going on? Well, what's going on is the maximum 996 tones is actually 80 megahertz, not 160. So why is it important for us for the operation? Like when we're testing Wi-Fi 6 with Rowell, we're always trying to refer to this to make sure that we were actually getting Wi-Fi 6 data rates, right? And sometimes in some of the equipment we use, if we were to just look at the UI on the CLI, we would see data rates, Wi-Fi 6 data rates, but next to it we would see like VHT or HT.
Yeah.
So we're like not sure, like is it HT? And then we look at the data rate and we see it's Wi-Fi 6. So sometimes we have to double cross the information that we got from the equipment we're using. Perfect segue to talk about the firmwares. So yeah, some of the challenges we had today is we would see a lot of rollouts of firmwares. And at a pretty fast pace, I guess. It makes sense because it's still the beginning, and they're trying to fix a couple of bugs. It might be important ones, it might be enabling new features that they worked on, it might be UI bugs, just like the one we talked about it. So you might see this in practice in the real life. If you start deploying AX, you deploy AX, you all IP with your customers, you have 200 APs working, and then the next day, boom, they released a new firmware version. So.
Yeah. Because there could be some features that weren't enabled at all, but prior to just releasing them, and then they include those updates afterwards.
Something else you might face in the real world is the incompatibility with all the APs. So if you take, for instance, like Cisco new controller 9800, it supports the AX APs, but it doesn't support the N access points. So if you still have N access points in your network, who still has N access point in their network? Yeah, well, what do you do? Well, you install a second controller, so it's harder to manage, and you have to think about all of that too in your operations.
And it's also not just incompatibilities with APs. You might have compatibility issues with clients. So one of the things that I've seen is you deploy Wi-Fi 6, but then some of your clients just don't operate very well. And so when you downgrade back to Wi-Fi 5, everything's fine. So a lot of this is test it before you massively roll out everywhere.
We put at the bottom should become more stable as we start seeing. General observation as well that we observed when we did our testing, interesting findings. 1024 QAM does work, but we only saw it on 5 gigahertz. The range is not that great. And what we saw is it worked better with the 4x4 AP. If you have a 4x4 AP versus 2x2 AP, we had the 2 and we thought that 4x4 was working better. You do get better data rates, but mostly due to 1024 if you're close enough to the access points. But what we realized as well is we had a lot more fluctuation in the data rates, right? Sometimes the clients that were trying to do 1024 to 156 QAM, so that was creating more fluctuation than what you have with Wi-Fi 6 currently.
And how far was your client from your AP?
I was not far, maybe 1-2 meters away. But while doing my test, like if I was to do a hyperv test, while doing the test, I would see in the packet capture later on that 2-3 different MCS index were used. I put it back, Wi-Fi 6 doesn't mean OFDMA. We're going to see a lot of OIDM traffic, especially if you're only testing with one Wi-Fi 6 device. There's a chance, they're not going to enable.
You might not even see OFDMA.
Spectrum efficiency doesn't seem to be at its best yet. So what I mean by this is the fact of reducing the subcarriers. The idea behind that it was to better use the spectrum we have available, the 20 megahertz or whatsoever. But in the hyperv test I didn't really see any increase in throughput when I was testing the same size between AC and AX. So I'm guessing this will improve as well as we start seeing more and more Wi-Fi 6 devices. You might need more power than PoE+. Happened to me too is 1 AP, especially if you have 8 streams like the 8x8x8x8x8. You might need more power than PoE. Okay, so
how did we analyze this?
Yeah, how do you do Wi-Fi analysis today? Yeah.
You've got multiple scanners around. So we use primarily MacBook Pros. So we use Wi-Fi Explorer. We connect our sidekicks to the Mac. For Windows, there's Wi-Fi application, and you can still use Ekahau for your spectrum analysis. And then if you have AirCheck and it's updated, you can see if you've got Wi-Fi 6 networks around. But for our primary analysis, I think it was done mainly on Mac OS for the both of us.
So the Wi-Fi scanners, they just look at the beacon frame. So if they're able to parse the HE information element, then they can discover Wi-Fi 6 networks. This is an example of Wi-Fi Explorer. You can see, I don't know if you can see, but you have a HE information element in the detail view. You can take a look at it. And this is WinFi. And you can see there's a column, the 802.11, it detected some AX networks here. In terms of, this is Ekahau. In terms of spectrum analysis, we can still use the same tool. I mean, we're just looking at the activity on the RF channel. We try to put, an example, OFDMA. We're not too sure if this is OFDMA. We're just playing with this yesterday.
Some of this was from actually last night as we were trying to get this to work.
Yeah, so it looks like 4 baby channels. So, so this is actually 20 megahertz, right? Central subcarriers is not used. That's why it looks like it's 2, but it's 20 megahertz. You have OFDM and then, well, maybe OFDMA. We didn't check the packet capture.
We didn't have a packet capture to actually see if it was 4 different RUs there.
And then to do packet captures, so you have different options. First, you need to have an AX NIC. Right, to be able to look at the AX packets. And 2 ways of doing it.
So the way I did it, the way I was only able to do it was using a Wi-Fi 6 AP. So I was using a Cisco 9115, and I would put that into sniffer mode and then stream that over to my computer with Wireshark. But I had a lot of limitations there because I was missing a lot of frames that I could not see. And we'll show a slide after that. And so I resorted to François. Although he's 3 hours away from me, he had to do the testing on his end to actually capture the frames and find more data to put into these slides and confirm that Wi-Fi 6 is working as we intended through reading the draft.
And the second option we have is to use the Jetson Nano. So it's running Ubuntu, so you can install AirCrack NG, and then you can leverage Airmon NG to actually put the Intel chip into the monitor mode, set the channel, set this channel width, and then do the packet capture, and that will save that into a PCAP NG file that you can later on transfer to your laptop and analyze with Wireshark. And this was actually the best option for us.
Yeah.
You get the new radio tap headers with the HE information elements.
Yeah.
So you get a lot more information in terms of the RF.
Yeah, I couldn't see the radio tap headers when using sniffer mode on the Cisco AP, and I don't know if I was just missing an option. I was just using the 9800 controller, and there's just a checkbox for sniffer mode. I talked to other people. I talked to the Wi-Fi ninjas over there. They confirmed that they also couldn't get it, but hopefully maybe an update will fix that.
And so if you don't use the 11AX NIC, this is what you'll see. So I think Peter showed that before when he was talking about multi-user MIMO, but if you're not careful, you just see acknowledgements all over the place.
But you can also see the RUs.
You don't see the data. So the process we used, and that's what we're going to do for the demo. So I'll go really fast here. So you can load Ubuntu on the NVIDIA machine. Then you install the driver for the AX card. You install Wireshark with the development version, and then you use Airmon NG to set the channel and channel width. That would put the card into monitor mode. Then you can open Wireshark, select the new monitoring interface, and start capturing AX packets. Save it, SCP back to your laptop to analyze it in Wireshark. I mean, you can analyze it on the small screen, but it's not very convenient, so that's what I was doing. So this is the process. We put everything here, the commands, how to get AirCrack, how to configure it to scan on different channel width. So that's the channel width supported by the Intel chip, so you can do up to 80. And then you will get the radio tap header, and you have the HE information element. And if you spend some time looking at this, that's when you start to see a lot of information. The guard interval, you start to see the MCS rate, the new one. And I put a link actually to the radio tap website where you can see all the fields, and you can start to drill into this. You can also see the spatial streams, the RU allocation if you do any OFDMA. Yeah. So that's pretty nice. And then just like Eddie said, you can create your new columns.
Some columns.
Yeah, that's pretty much what we did on our side. We tried to look at remote packet capture options because it's nice to have the Jetson Nano somewhere, and then we just do it remotely. Aero dump, it worked, but we didn't get the radio tap headers, so it wasn't as convenient, right? And then SSH dump, Adrian Granados talked about this on Twitter, but I didn't have time to test it out. Maybe we can leverage that to make it work in the future. Come on, did you try it out? No? No. All right, so we'll see. Wi-Fi 6 design. So we still have a couple of time.
How much changes? Yeah, that's good.
Yeah, so my question was, does it change anything? The answer is not really. I mean, we're still going to design for 20, 40 megahertz wide channels for now. Maybe when we go to 6 gig, we can leverage those bigger channels. And then some questions raised, right? How do we do capacity planning, right? With OFDMA and all the new efficiency changes.
Yeah, the design tools don't have those features implemented, so we can't design with OFDMA in mind.
And also, like, implementation of OFDMA might change from one vendor to another, so you're going to have to find a tool that does everything. And then if the vendor changes the implementation, then it's going to get complex. Then do we plan for 1024 QAM?
No.
I would say no. It's I call it the icing on the cake. I mean, if you can have it.
If you can get it, cool.
Yeah, but the cell size will be much smaller if you do. And then how do you calculate TCI if you have BSS coloring, right? So that some of the challenge we might have when we start designing for Wi-Fi 6. And plus we have to support those damn Wi-Fi 5 legacy devices. So. So should we upgrade our infrastructure to support Wi-Fi 6? That's the question everyone is asking, right? Your boss is coming to you. Should we buy those APs? So some considerations we have here. Look at the Wi-Fi 6 certification. The APs, it's certifiable, compatible, Wi-Fi 6 compatible, and so on. Also, we are still using the first generation of Wi-Fi 6 access points, so keep that in mind. Do some testing, make sure that it works, make sure that also the legacy devices works with your brand new Wi-Fi 6. And then 6 gig is coming soon, right? We keep hearing about 6 gig and how the frequency becomes available, but 6 gig for us, it means new hardware to support 6 gig, so new access points. So what do? Do I wait for the new 6 gig access points? Do I upgrade now? So I guess it depends on there's no right or wrong answer. It depends on your life cycle of when you're supposed to refresh your equipment. Maybe it makes sense for you today. Maybe it makes sense for you to wait for the next generation of Wi-Fi 6 access points to come along. And the good news is the clients are definitely coming to market. So hopefully it's going to speed everything else. And we started to see with, I don't know if the launch of the iPhones 11 and the publication of the Wi-Fi 6 certification was like lined up. But that pretty much started the kickstart, we got a jump start, and we're going to start seeing a lot more Wi-Fi 6 devices, right? So good thing we did the presentation today. If you did it in 2 months, it would be more complex. Okay, demo time, 15 minutes. So for the demo, yeah, remember how we said it's early stage? So that was me 2 hours ago trying to.
Just an hour ago. I'm just the guy watching.
So we had some minor setbacks we had to fix.
All right, so this is our setup. You want to get set up?
Yeah, you can talk about it.
So this is our diagram here for how we're doing the setup. I'll stand over here actually. So we have our Aerohive AP. We got a switch thanks to Eddie, Keith, and Ferney for setting that up. And also we have a bunch of WLAN pies. I think we have 8 of them. And what we're going to do is try to implement a test here. So if you have a Wi-Fi 6 device, we've got iPerf 3 running. We have an SSID broadcasting, and I'm going to practice my French here. Champion du monde.
Yeah.
There you go.
Perfect.
That's the SSID name.
I don't know why I chose this one. I just.
Canadian.
Not for football. So yeah, the password is Wi-Fi 6 WLPC. Let me see if I can. Can I do?
And so now you could use the option to do reverse if you want. I think we should do both. Have a couple of you guys doing reverse. Have some not having that reverse option, so we can get some dynamics here. And we have a sidekick here, so we can try to see what that spectrum's going to look like, and we're going to try to get some baby RUs. Because we couldn't get that last night. We only had 3 devices, and it was late. We were hungry, and we broke Mike Albano's lab, so sorry.
Okay, so whoever has a Wi-Fi 6 device, please take it out. Do you see the SSID? Can you connect? Okay.
So we're also we're using an 8-port switch. The WLAN pies are down here, so if you can't see it, you can come see it later. We needed more ports, so we've got some micro ticks here, just bridging the connection. We have the Aerohive AP, which is actually plugged into an Exceltex battery, which then connects back to the switch. Then we have the Jetson that Francois is going to use to capture some frames. And we only tested this twice, okay? I'm connected to it right now. I'm doing an iPerf test. Now, if you can't do the iPerf test, it's because somebody already got to that server on that port. And then let me give you the IP addresses. Maybe that would help.
Should we assign them? Should we assign those to something?
No, whoever gets it first.
Okay, so let me share my screen.
Live dangerous.
Yeah. Can you guys see what I see? Okay, so let me just SSH into the WLAN pie.
Everyone turn around.
For what? For my password? Okay.
not sure your iPerf's
Okay, so we got a couple of clients. Got Rene, Magnus, thank you
Hold
guys.
on, I have a list of IPs.
Okay, so we got a couple of clients.
15 is not on.
Then I'm going to connect to the Jetson Nano, right? SSH into it. Hopefully it kept the same IP address. It did, okay.
Yeah, I know.
Okay, so if I look at my network interfaces here, you see I have the WLAN 0, so that's pretty much the AX card, right? Then what we need to do is we need to place this card into monitor mode on the specific channel we care about. So you can do airmon, NG for that. You do start, and then you specify your channel. We're using 112 here. And I'm not going to specify any channel width because we're using 20 megahertz, but if you were to do it on 40, you would set up the proper channel width. And here, if everything works out, they tell you that everything works out. I'm not sure if it did. And then what we need to do is we need to start Wireshark, and in Wireshark we should have our monitoring interface. I don't know if it worked.
.99, I'm getting a 2 address.
On the Wi-Fi?
What do you have?
Dot.
I'm getting a .2 address. I mean, your screen is .99.
Yeah. Try again, because I connected my MacBook with the sharing, and it has the DHCP server, so probably messed up.
That's why. Yeah, what IP address did you get? Yeah, okay. So you turned off your sharing, François?
Yeah, I turned it off. So are you guys generating some traffic? Are you guys doing some hyperf?
What was the server IP address?
15 to 25.
192.168.99.15 through 25.
And then you'll get the server.
Yeah.
You're still getting a .2.
We're still getting the .2, so
It's taking it .2?
There it goes.
okay, I'm trying to write traffic for you now.
Thank you, Blake. Thank you. If you're getting a 192.168.2 address, just try to ask for a new IP address, because
I totally cleared out and back.
Yeah, it's to come back? Okay, so... you want the address for the server? Okay, so do you know it's...
It's 192.168.99.15 through 25. Just try, if you can't connect to it, it's already used.
So here, if you we just open Ekahau to look at the spectrum, you can also see Ekahau detects the SSID, and then you have a nice AX icon with a new color. And here, this is what we see, all right? So this is it OFDM, OFDMA? Sounds like it looks like OFDM. And so now if we, what type of data rates do you guys have? Anyone's doing IP server? Now if I want to go and capture the traffic.
195.
195? And that's why okay. And then so if I go back to I forgot to specify the interface. That's why it didn't work. 0 and then 112. No. Yeah. So now it's telling me WLAN 0 mon, and that's the one you'll be looking for in Wireshark. When you open Wireshark, you're looking at capturing the traffic on this one. So if you restart Wireshark, and so that's the manual work we had to do, right? We had to go back on the Jetson Nano, open up Wireshark in Jetson Nano. I would usually SSH into Jetson Nano to do that, to change the channel width and so on. And I would go back to my small screen, open Wireshark, select the proper interface. Yeah. Double click on it. You can double click on it.
This keyboard's weird.
Yeah, and then it doesn't work.
You don't have permission. You have to run it in.
Oh yeah, you have to do sudo Wireshark. Yeah, you have to do sudo Wireshark when you open Wireshark. Yeah, and then and sometimes, like in Wireshark, when before selecting an interface, you're going to see a little graph telling you if you're receiving frame on that interface. Sometimes it didn't work for me, so I would just go back, stop the monitor mode, restart the monitor mode, and then I would start seeing some traffic. And so I'm just going to stop it. So after that, we would stop it, and we would save it on the NanoPi. So you can just use the name you want, WLPC, we'll call it WLPC. And then what you have to do is, so if I go back here and I look at my, I have the WLPC.pcap.ng. Now if you want to try to transfer that back to your computer, you have to change the write, so you actually have the permission to do it. So I would do, oh, okay. And then now, if I go back to my laptop, I can actually do the SCP.
Change the name, yeah.
And it should work. And so right now, I'm transferring the PCAP over, and I now have it on my laptop, so I can go ahead, open it with Wireshark. Where did I put it? Probably in the demo folder. And now you can open it in Wireshark and start analyzing your packet capture. So if I take, let me take a random data frames. So if I took a random data frames, it's a little small. You guys can see that I can see the HE information in the radio tab header, and if you drill down enough, you'll be able to find the MCS information and so on. And the MCS field is changing, right? So the one we use, the filter, if you have a filter in Wireshark that you use for Wi-Fi 5 communications, it's not the same filter anymore for Wi-Fi 6. So I now have two columns, the MCS one for Wi-Fi 5 or AC, and then I have a new one. Data MCS, you see over here, and this is the one for Wi-Fi 6. So you can see the MCS rate that was used. And so if we try to sort this by MCS, let's try to see if we got some 1024 QAM action going on. Where is it? Here. We didn't. Let me go back all the way at the top. So the best we did here was B. Awesome. So B means 11, MCS 11. So we actually did get some 1024 QAM traffic going on here. Okay? Are we past the time?
Yeah.
Okay.
Can I comment on one thing?
Yes.
Why you didn't see OFDMA?
Yeah.
Okay, and here's why. We use a Broadcom chipset, like the majority of AP vendors is either Broadcom or Qualcomm.
Yeah.
The SDK from Broadcom that does the actual RU allocation was literally supplied to most of the vendors about a month ago.
Okay.
So that's why most vendors are just now submitting their APs for Wi-Fi Alliance certifications. If you did this test in about a month, you'll see the baby channels.
Okay.
Okay.
So,
but everybody's kind of in the same boat. Already some of the clients support the RU allocations, but the software development kits have just now come to the vendors. They're getting their firmware out. They're actually in the process of getting their APs tested right now, and they're all required to support 4 RUs.
Okay.
But right now, the version of firmware you're using on that AP, and probably most of our competitors right now, cannot simply do the RU assignment yet. In about a month, you'll be able to see that.
Yeah. So it goes back to our previous slides about testing it, looking at the Wi-Fi Alliance certification, and seeing what's supported. So again, and like you said, once those updates come out, then we'll start seeing more of these features get implemented across the board.
thank you. Thank
But
you.
you saw the qualm.
Yeah. So I guess what we saw earlier wasn't OFDMA, so now we know. So we are having a Wi-Fi 6 party tonight. Woohoo! So we're going to have one room, Zurich 1. I think it's the one here. 7:30 tonight. If you want to just join us to do more Wi-Fi 6 tests, if you have Wi-Fi 6 end devices, if you have Wi-Fi 6 access point, just bring them along, and we'll do packet capture, and we'll try to see if we can generate some traffic and see, analyze what we see together. Sounds good?